ordered a total of 15 tricycles and bicycles from a sporting goods store. The number of wheels, ooh, this is tricky. The number of wheels for all the tricycles and bicycles totaled 38. Write a linear system of equations that models the scenario where T represents the number of tricycles and B represents the number of bicycles. Okay. So our goal is to write a system of equations. So that means we're going to be writing more than one equation that models the scenario above, where there's a total of 15 tricycles and bicycles, and the number of wheels for all the tricycles and bicycles totaled 38. Okay, so let's picture it, right? A tricycle is going to have one big wheel in the front and then two wheels in the back, right? I don't even know how to draw a tricycle like a, I don't know, that looks like a lawnmower or a dog, whatever. And then a bicycle has two wheels. So that also doesn't look like a bicycle, but you get the idea. We have 3 wheels on a tricycle and 2 wheels on a bicycle. Total number of wheels is 38. So I have my two equations. It looks like the t-axis is the x-axis and the b-axis is the y-axis. So just for the purposes of being able to put this into my calculator, I'm going to let t be represented by x and b represented by y. That doesn't look like y. By y, okay? So what I'm entering into the calculator is x plus y equals 15 and 3x plus 2y equals 38. Okay, so if you'll notice, both of these equations are in relation mode, so I'm going to keep that in mind when I'm entering them. Stop being annoying. Okay, there we go. So I've got x plus y equals 15. All right, let's go ahead and change the window so I can see what's going on. Okay, great. I'm probably going to go from -10, or not negative. Look at my graph here. It goes from, it actually gives us the window. The x-axis goes from 0 to 20. So let's do that. Let's go from 0 to 20. And then the y-axis goes from 0 to 20 as well. We'll go ahead and do that as well. Okay, 0 to 20. Okay. All right. So then let's get our points here. Okay, so the first point is going to be 0, 15. Then I've got 2, 13. I'm just skipping a few, so I'm not making like 700 points. 4, 11. 6, 9. I have no idea what's going on. Do you hear that noise in the background? And I have 8, 7. 10, 15, or 10, 5. Wow, we're going to be here a while, aren't we? Okay, 13, 2. And then 15, 0. Okay, so that was my first equation. And then I've got 3x plus 2y equals 38. I'm going to label this guy. All right. right. Now let's go ahead and get some points here. Oh, I'm still on the red line. I want to be on the black line. There we go. So the y-intercept is 0, 19. So 0, 19. Oh, we're all the way at the tippy top here almost. Okay, 0, 19. 2, 16. 4, 13. 6, 10. 10, 4. 12, 1. And then 12.70. Okay, so it's going to go somewhere right before 13. It's going to hit the axes there. Okay, so I want to get the point of intersection right. Let me just double check where that was on the graph. Okay, they intersect at 8, 7. Okay, so 8, 7 is the point of intersection. Okay, cool. So the name of this one is 3t plus 2b equals 38. The reason why I'm writing the equations in terms of t's and b's and not x's and y's, I just did it in x's and y's so I could enter it into the calculator. This is what the question wants you to answer in terms of, because they say that you have to write your system of equations where t represents the number of bicycles and b represents the number of bicycles ordered. If you did it in terms of x and y's and you didn't explicitly state like I'm making all t's become x's, I'm making all b's become y's, then you would not get full credit. So go ahead and make sure that you keep using the variables that they want you to use.